Happy morning, students. Today we are going to see the power plant engineering class number 2. The class number 2 we are going to see vapor power cycle. In the previous class we discuss about what are the different energy sources available in India. That is, we are discussing the topic of power scenario in India. Today we are going to see vapor power cycle. What do you mean by vapor power cycle? The vapor power cycle is how the vapor is converted into a mechanical energy, how the vapor is converted and what way it was converted. Those things we are going to discuss in today's class. Today's class we start with the Rankine power cycle. What do you mean by Rankine power cycle? It is a very simple cycle. In this vapor power cycle, the Rankine cycle, the water is coming from the pump. Water is coming from the pump with the high pressure. Right? The water is coming from the pump at high pressure. That water is entering into the boiler, with a high pressure. In the boiler, the water is converted into a vapor form. Water is converted into vapor form, from liquid to vapor. So liquid to vapor conversion is taken place inside the boiler. That vapor is raising its temperature at the superheated level. We call it as a superheated steam. Right? That superheated steam is coming out from the boiler. From the pump, the pressure is raised. Inside the boiler, the temperature is raised. Pressure is raised, temperature is raised. So the vapor is at the high temperature as well as the high pressure. The high pressure and high temperature vapor entering into a device, what we call it as a turbine. Inside the turbine, it enters at the high pressure and high velocity as well as with the high temperature. High pressure, high velocity and high temperature. So it was entering into a turbine with a high pressure, temperature, pressure. It starts rotating the blades. Once it starts rotating the blades, the kinetic energy is converted into a mechanical energy. So that mechanical energy is utilized for generating the power. So the turbine rotates the generator. So the generator produces the electricity. Once it was expanded inside the turbine, the high velocity, high pressure, high temperature steam entering into a turbine and expands it, performing its mechanical work. So after expansion, the steam loses its temperature. Once it loses its temperature, what will happen? It slowly coming as in water. When it coming out from the turbine, it contains water as well as vapor. It is in wet stage. What we call it as wet steam. The wet steam entering into the condenser. Where it is completely condensing. Right? The whole water vapor is converted into water. That water again goes to the pump. Again pressure is raised. It is going for the circulation. It is a closed loop system. It is going to be a closed loop system. So if you are coming for this diagram, TS diagram or with the block diagram, first we will see the block diagram shows the pump. From the pump, the water is pumping to the boiler. Right? In the boiler, there is a Q in, what we call as heat addition. Burning of the fuel, the heat is generated, the heat is added to the water, and expands to the turbine. Again wet steam coming to the condenser. In the condenser, heat is removed from the steam and from the wet steam. The heat is removed. What we call it as heat rejection. Heat rejection process. In the boiler, heat addition. In case of a conduction, heat rejection. Heat addition in the boiler, in the condenser, heat rejection. Then again it is going further. So if we are coming for this TS diagram, is going to be a temperature versus entropy diagram. All the cycles will be explained with the TS diagram. That actually, if we see this one, it starts at the point number 1. The point number 1, the pump starts pumping. It reaches a point 2. In the water level. Then from this 2 is the entry of this boiler. The point 1 is entering at the pump, entering in the pump, right? Then it is coming out at the point number 2. The pressure is raised. Then this point number 2 is at the entry of the boiler. Point 2, the entry of the boiler. So the heat addition process starts at the point number 2. The temperature addition starts at the point number 2, that is inside the boiler. So you can see there the temperature is from 0, that is 32, around 60 degree or 70 degree temperature raises to the 2. That 60 degrees reaches, then it is going inside the boiler. It is going inside the boiler from point number 2. It is going on, the temperatures go on, raises, then the saturation temperature, then from the saturation it reaches at the point number 3 as a superheated steam. Superheated steam coming out from the boiler. From the pump, entry of the pump is 1, exit of the pump is 2, the same is going for the boiler. From the boiler, temperature is raised from 2 to 3, point number 3. Then point number 3, it enters the turbine. It enters the turbine. In the turbine, it performs its work, right? The temperature is reducing because it is performing its work. The temperature as well as pressure drops. Pressure drops, right? Then up to 4, it was expanding. Up to 4, it was expanding inside the turbine. Expanding inside the turbine. So the turbine entry is point number 3. Turbine exit is point number 4. From the point number 4, it reaches the condenser. It reaches the condenser. It reaches the condenser. So the temperature remain constant. Temperature remain constant. Entropy is reduced. Entropy is reduced. Entropy is removed. Right? Complete heat is removed. Then it is coming to the liquid stage. Complete liquid stage at the point number 1 again. Point number 1 again. Again it is going up. I explain again. From the pump entry is point 1. This point 1 and this is the point 1. Then the pumping is taken place. The pressure is raised. There 2. Point number 2. Alright. Then point number 2. Here it is going to be in point number 3. The heat addition process. The entropy starts increased. Entropy starts increased. Enthalpy starts increased. Entropy starts increased. Then 3 to 4 is the work done. 3 to 4 is the work done. And then 4 to 1 is going to be a condensation process. 4 to 1 is going to be a condensation process. So that is a cycle. 1, 2, 3, 4 is a cycle. That is what we call as vapor power cycle. If you see this one, where is the heat addition process taken place? Heat addition is taken from 2 to 3. Heat addition is performed the Q to Q internal. Q addition, Q in. That is 2 to 3. And heat rejection is 4 to 1. Work done is 3 to 4. Work done is 3 to 4. In this 3 to 4, work is done by the turbine. By the turbine. That is we are getting the work. We are taking the work from the steam. But if we are coming for this 2 to 1 is also work done, or 1 to 2 is also work done, it is to the system. 2 to 1 to the system, 3 to 4 from the system. What we are taking, what we are utilizing. So with this we can calculate the efficiency of this cycle. So if we go for the cyclic process, what are the different cycles? If we go for the cycles, 3 to 4 is going to be a reversible adiabatic expansion. Reversible adiabatic expansion. That is a work done. Work done the system. 3 to 4 is the expansion. Steam expand inside the turbine. 4 to 1 is a condensation process. Condensation process. The pressure is remain constant. We are removing the temperature. We are removing the temperature. And then 1 to 2. 1 to 2. Right? That is going to be a pumping process. 1 to 4 is going to be a pumping process. The feed water is going to be pumping. And then from the 2 to 3 is going to be heat addition. Heat transfer. Heat addition, where it is taken place? In the boiler. It is taken from the constant pressure. 1 to 2 is a raising. Temperature pressure is raised. The raised temperature remain constant during the constant heat addition process inside the boiler. Inside the boiler. Right? So these are all the two adiabatic process. The first adiabatic process is expansion inside the turbine. Right? So another adiabatic pumping. Adiabatic pumping process. So two constant pressure process and two adiabatic process. Both are reversible. Both are reversible cycles, right? Then if you're going for the efficiency, what is happening in the boiler? Entropy, what is the change in enthalpy? Right? That is going to be in heat H3. H3 is the enthalpy enters, right? That is equivalent to how much is the heat addition? Q3 is the heat addition. Plus how much is the wet stream having enthalpy? That is HF1. HF1. So Q3 is going to be in H3 minus HF1. Right? That is Q3 is what we call as heat addition supplied to the boiler. That is from the point number 1 to 3. In the cycle, if you see this graph, it is going to be in, you can see this graph. So 1 to 3. 1 to 3 is going to be an addition, heat addition process. That is what the called as in Q3. Right? So if you have to find out how much work done on the turbine, work done on the turbine, work done on the turbine is going to be in H3 minus H4, H3 minus H4, right? That is the enthalpy change is given, right? So another is going to be in, so how much work done by the turbine we calculated. Then we have to calculate how much on the pump. How much on the pump? It is going to be in, see this one, H2 minus H1, H2 minus H1. So most of the cases, the H2 minus H1 will be negligible compared to the pump work, that is turbine work. The pump work is negligible. Pump work is negligible. So we are not considering pump work in most of the cases. Most of the cases we are not considering the pump work as it was negligible, as it was negligible amount. So that is what the pump work. WP is equal to V3 P1 minus P2. Or is this is given in terms of enthalpy entropy, it is going to be HF2 minus HF1. Both are in the liquid stage.